So on my screen, I have the drawing for the crankcase radial engine, and I'll be toggling back and forth between the Mastercam file. This is at the stage or the level of completion where we left off. And just to get an idea where we are, I will run the part and verify. You can see I have one stock model and one toolpath. So I'll select the entire toolpath group. You see checks next to both toolpaths or the stock model and the toolpath, and I'll run it and verify. And you'll notice that you don't see the soft jaws inside of verify, or you don't see the fixture inside of verify. And that's probably something that we should bring in just in case if we have a collision between the tool and the soft jaw or the tool and the fixture, verify would be able to point that out for us. So I want to take advantage of that. So I'm going to back out of verify. And to have these two soft jaws show up inside of verify, what we can do, here we have the verify icon. To the right of it, simulator options. Click on simulator options. Then it brings up this dialog box. Towards the bottom, you'll see fixtures. Check fixtures. And you'll see that says levels. You want to activate the levels or check the levels where your fixtures or your work holding reside. And in our case, soft jaws. So I'm going to check level 8. I'll select OK. I'll save my work. And now if I go back into verify, you can now see that we have the soft jaws inside of verify. And if a collision happens with the part or the fixture, it will stop. So stop condition, collision is turned on. And I'll run it. Looks good. So from here, I'll exit verify. And we're now ready to start creating more toolpaths. Before I move forward, are there any issues? Anyone have any questions about making the soft jaws or the fixtures visible inside of verify? Everyone's good?
Yeah, we're good.
All right, nice. Okay, so the next thing that we're going to do is we're going to machine the outside profile. And for the time being, I'll make the material level invisible. That way I can access or easily access the geometry on the part itself. And once I select the chain that I need to drive this toolpath, I'll make the material level visible again. So we're going to use a contour toolpath. And we're going to machine the outside profile. I'll select it here.
I have a question.
Yes, sir.
Should we make our stock model first?
Yeah. Oh, thank you very much for pointing that out. So last class we left off with the toolpath. We didn't create the stock model that reflects the facing operation. So thank you for pointing that out. Let's do that. So I'll go back to the toolpath manager. We've got a stock model that shows or reflects the material prior to machining. Let's make one that reflects the facing operation. So to do that, go up to the toolpath tab. Select stock model. And for the name, let's call this facing operation. Stock plane, leave it at the top. And for the initial stock shape, we have a stock model that represents our material. So I'll select stock model. And the only stock model that's currently available is the raw stock. From here, I'll go to source operation, and I'll select the toolpath that's actually machining the stock model. So in this case, I've selected the facing operation. I'll select OK. Now it's difficult to see because the material representation or the solid that represents our material is currently visible. It's overlaying the material or overlaying the stock model. So if I go to the level manager, make the material level invisible, and I still have translucency turned on. So for the time being, I'll turn translucency off. And you can now see that this gray representation of our material, that's our stock model. So I'll go back to the toolpath manager. with the stock model selected, I can select toggle display. And this would be a good time to save my work. Thanks, Josh. How's
Thank
everyone
you.
doing?
All right.
Good.
Nice. All right. So from here, let's machine the outside profile, and we're going to use a 1-inch flat end mill. We're going to rough and finish. This is aluminum. We're going to rough and finish with this 1-inch flat end mill. So we'll go to toolpaths. We'll go to 2D toolpaths, and we're going to select contour. And I'm going to select the outside profile right here. And right now I've got solid chaining turned on. I could use solid chaining, but I'm going to change back over to wireframe chaining. So wireframe chaining, the mode is set to C-plane, and then the selection method is chain. If I look at the part, this is the movable soft jaw. This is the one that's facing the operator. I'm going to select this top edge right about here so that the chain goes in a clockwise direction. Once I see it going in a clockwise direction, I'll select OK. And that brings up the parameters for this toolpath. From here, go to Tool. We're going to add a 1-inch flat end mill to our tool list. So I'll go to Select Library Tool. The filter is currently active, so I'll select Filter. And I'm going to deselect all tool types and then select the 1-inch flat end mill, or select flat end mills and set the tool diameter equal to 1. I hit enter. I'll select OK. And I've got one tool that fits that description. It's tool 297 coming out of the library. When I double click on it, it should be added to your tool list as tool number 2. How's everyone doing?
Good.
Doing good? Okay. We'll need to edit this tool definition. To do that, right click on it and then select Edit Tool. Under the tool geometry page, I'm going to accept the defaults. And I'll just remember that the shoulder length, this is what I'm going to use as my tool projection when I bring in a tool holder. So shoulder length is 2.5. I'll set my tool projection to 2.5. We'll go to the next page. Tool number, this is all good. Let's set the number of flutes to 3. To calculate our RPM, I can select the calculator. You see it's calculating the RPM at 1,146 based off of this 300 SFM. To turn the coolant on, select Show More Options. Select Coolant. And then where it says Flood Coolant, set it to On. This will generate an M8 in our NC file. From here, I'll select OK. For the finish XY step percentage, set this to 2%. And just to recap what we did, we set the number of flutes to 3, we calculated the RPM, we turned the coolant on, and then changed our finish XY step percentage to 2. From here, I'll select Finish. That brings us back to this page. The RPM is good, but we'll need to adjust the feed rate. The FPT, let's set the FPT equal to 1% of the tool diameter. So for the FPT, 1 times 0.01 is 0.01. It's calculating my feed rate at 34.38. Set the plunge rate to half the calculated feed rate. So 34.38, divide that by 2. And also change that up. So I've got my feed rate, my plunge rate calculated. For the comment, I'll borrow the tool name. I'll paste it down here. Then I'll provide some type of useful information. We'll say machine. And this could be all caps. Once it gets converted into an NC file, it's going to be all caps anyway. So let's keep my cap lock on. Say machine outside contour. And I've got rapid retract checked. And that'll complete everything we need to change on this page. How's everyone doing?
Pretty good.
Good. Thank you. From here, go to the tool holder. And from this library, you pretty much see all different types of tools. We're using a Cat 40 tool holder. So let's go to Open Library. And from this menu, or from this window, select Cat 40 inch. So CT40-IN. Select Open. And now we only have Cat 40 tool holders to choose from. And we're looking for a solid type tool holder. So this will be a C4, I'm guessing an E3 1000. So C4 E3-1000. This will be a solid type tool holder. It'll have a set screw right here, and the set screw will need to land on a flat that's ground onto the shank of the tool. For the tool projection, set it to 2.5. And something I didn't check, and I should have checked. The cut length of this tool.
I have a question.
Yes, sir.
How do we know our tool holder is not going to hit the top of our part?
That's what I'm thinking about right now. I didn't check the cut length. Now I'm throwing it in reverse, and I'm thinking the cut length needs to be greater than the length of the part right here. And if all else fails, we missed it, hopefully we would catch it in backplot, and we would definitely catch it in verify. So let's back up a little bit. Well, first off, we got a couple of things that we can check. Here's the drawing. I'm in the middle of something, so it's not letting me go there. I'm looking at the drawing on my other screen. The thickness of the part is 2 1/4. So let's go back to the tool, edit the tool. And you see the cutting length? We're going to come up short. So we're going to have to order a special tool for this. We're going to need a greater length of cut. And without looking at a tool catalog, I can only guess. So let's do this. Let's set the cutting length to 2.5. And then let's set the overall length of the tool to 5. Now, what you would need to do is you'd need to look this up in a tool catalog, get the exact numbers before you fill all this information out. I'll set the shoulder length to 3. And this will become our tool projection right there. So the tool projection will match to our shoulder length. These numbers I pulled out of the air. What's important is that the cutting length is greater than the depth of the contour. So what you would really need to do is look at the tool that you're buying or the tool that's available to you and get all that information based off of the tool, or I would recommend the tool manufacturer's drawing of the tool. I've actually sat there and measured the tool before. It's like, okay, the cutting length is 2 1/4. So I would have manually measure the tool and then fill out all of this information. So from here, I'll go back, I'll go to next. All of this should be good, but when I select finish, my feed rates are going to go back to the default value. So once again, set the feed to 1% of the tool diameter, so 1 times 0.01. Set the plunge rate to half the calculated feed rate, so 34.38, divide that by 2. And that should complete this page. We made some changes to the length of the tool. Let's check on the holder. Yeah, so this defaulted back to its original setting where the entire length is the tool projection. Set the tool projection to 3. And that should work for us in this case. How's everyone doing?
Good.
Good? Yeah, so that would have made itself obvious, or we would have noticed it when we went into backplot. And if we didn't catch it in backplot, we would have definitely caught it in verify. All right, so from here, we'll go down to cut parameters. Manuel, you good?
Yeah.
Okay, cool. I'm getting a lot of background noise from you, so I'm muting
Oh,
you.
yeah, back. Okay.
Yeah.
All right. I'm gonna.
Yeah. So don't take offense. I'm just muting you because I'm getting a lot of background noise. But if you got a question at any moment, unmute yourself and feel free to ask. All right.
Okay, definitely.
Okay, thank you. All right. So from here, we're on the cut parameters page. Compensation type, we're going to use where in this class. For the compensation direction, we use cutter comp left. We'll accept the defaults here. I'll check real quick. Make sure contour type is set to 2D. And then go down to stock to leave on walls and stock to leave on floors. We'll set these values to 0. We're going to machine right up to the model. So that'll complete this page. We'll go to depth cuts. I've got depth cuts turned on, and the default setting that we're using, remember when we checked use tool, step, peck, and coolant? So the maximum rough step down is 50% of the tool diameter. So in this case, 1/2 inch. And I've got keep tool down checked. This will prevent it from retracting to our clearance plane after each depth of cut. So from here, I'll go to lead in, lead out. These are my default settings, 25% for the line and the arc on the entry and the exit. So this page is good. I could turn breakthrough on, and that would just tell it to go slightly beyond what we identify as the bottom of the part. Doesn't hurt. So let's add 20 thousandths for a breakthrough. For multi-passes, let's activate multi-passes. Let's set our number of finished passes to 1. The spacing for our finished pass is 20 thousandths. That's coming from that XY step. That's coming from that XY step over percentage that we set back in the tool settings. And I'm also going to check machine finish passes after, let's see here. Keep tool down, machine finish passes after roughing all contours, machine finish passes. Oh, right here. So finish passes. This is a slight change with this release of Mastercam. Now where it says finish passes, it's a drop-down menu. I'll set it to final depth. So when it gets to its final depth of cut, it's going to do several roughing depths or several depths of cut. And then when it gets to the, well, let me rephrase that. It's going to do several depths of cut, intentionally leaving 20 thousandths on the walls. And then when it gets to its final depth of cut, it'll do one rough pass. And then it'll go in and it'll do one final pass where it removes the 20 thousandths all in one shot. From here, and I'll also check keep tool down. And from here, I'll go to linking parameters. Let's turn on clearance. And let's set the clearance to 2 inches above the top of the part. Now remember, the origin is on the soft jaw. So to set it to 2 inches above the top of the part, I'll select clearance. I've got it set to absolute. I'll select clearance. I'll let my cursor lock on to something that represents the top of the part. And then I can type in +2. So now I've set the clearance plane to 2 inches above the top of the part. For the retract, if we're going to use it, let's set it to absolute. And let's set the retract to 1/4 inch above the top of the part. So I'll select retract. Once again, I'll let my cursor lock onto the top of the part. And in this case, I'll type in plus 0.25. Feed plane, I'll set it to 0.1. I'll keep it at incremental. For top of the stock, I've got to set to absolute. Now this value is coming from the chain that's driving it. So if I select top of stock, it should be the same. It is. For the depth, I'll set that to absolute. I'll select the depth icon and I'll tumble the view. I want to lock on to something that represents the bottom of the part. Now, that's not the bottom of the part, this edge right there. So I'm going to move over to here. This endpoint represents the bottom of the part. And you can see that the bottom of the part is 105 thousandths above the top of the vise. So we need to be careful. We want some clearance between the part and the vise. We don't want to machine into the vise. Just remember, we did use a breakthrough of 20 thousandths. So in reality, the Z position will only be 85 thousandths above the top of the jaw, which is still plenty of clearance. Just be aware of it. So from here, I'll select OK. I'll look at it from an isometric view. And what I'll do is, with just this toolpath selected, I'll run it in backplot. And there were some issues with the tool, so let's make the tool holder visible. Let me rephrase that. There were some issues with the tool holder. So let's make the tool holder visible. And if I hit the S key repeatedly, I can single step through the whole process. So it's making these roughing passes, and it's intentionally leaving 20 thousandths of material on the wall. And let's see, there's our third depth of cut. There's our fourth, and there's our fifth. And this one brings us 85 thousandths above the top of the jaw. It'll do one roughing pass, and then it's going to reposition itself, and it's going to go in for one finish pass at the final depth of cut. And you can see that it's stepping 20 thousandths closer to the part. And then it retracts away from the part. So I didn't see anything out of the ordinary. I'm not seeing any green lines or feed moves or rapid moves going through the vise or the part. So I'll exit out of backplot. I can toggle off the visibility of the selected toolpath. I'll select toggle display. I'll look at it from an isometric view. And this would be a good time to save my work. How's everyone doing?
Good.
Okay.
Nice. No issues? Nothing I can help resolve? All right, so from here, select I save my work. Select the entire first operation toolpath group, and then run it and verify. Stop condition collision is still turned on. And then I'll select play. Looks good. I'm comparing the machine model to the wireframe representation of the part. If I zoom in down here, you can't see the geometry that represents the bottom of the part. So if I change over to a translucent view real quick, so where it says visibility, check stock or select stock, and it changes over to, it goes from a check to a square in this box. Now, if I look at it from a front view and I zoom in, here is the bottom edge that we machined to, and here is the bottom of the part. So there should be a 20 thousandths gap between the two. We told it to break through 20 thousandths. And that's okay as long as we don't cut into the jaw of the vise. Even with soft jaws, you cut into them, it's just a mess. So try to avoid running into them. And one thing I will recommend, if you ever do cut soft jaws and you cut them on the machine, highly recommend deburring them while they're on the machine. Don't take them off, just deburr them while they're on the machine. And you'll save your operator a lot of grief, because I've been in situations where people cut soft jaws, they don't deburr them, and they go into a production mode, and next thing you know, the operator gets injured. So it's always a good idea to knock off any sharp edges that are created from the machining operations. So from here, I will go back to a shaded view. I'll close out of verify. I'll look at it from an isometric view. Let's now create a stock model that reflects the contour operation. To do that, I'll make sure the insertion arrow is at the very end of my toolpath group. I'll go to the toolpath tab, and then I'll select the stock model. For the name, let's call this outside profile or contour outside profile. Just make sure make sure you use something that makes sense. For the initial stock shape, once again, I'm going to use a stock model, and I'll use a stock model from the previous operation. So facing operation. And then for the source operation, I'll select this new contour toolpath. I'll select OK. And there's a stock model that reflects all of our machining operations up to this point. With the stock model selected, I'll toggle off the display. How's everyone doing? Doing good?
Yeah, we're good.
Nice. All right. So now I'm looking at this part, and we've got a big pocket that we need to machine. And the problem with this pocket is the chips don't really have a good place to evacuate to. And you'll get a lot of recutting at chips in a situation like this. So something that we could possibly do to alleviate that problem, we've got a hole that goes all the way through the part. So why don't we drill this hole so that it goes all the way through the part and all the way through the material? And that'll give the coolant someplace to drain, or give it somewhere to drain. And when the coolant drains, possibly carrying out some of the chips that are building up inside of this pocket. Can't say it's might not actually happen, or there's no guarantee that all the chips are going to get evacuated, but it would probably help. So let's do this. Let's create 6 pilot holes with a 1/2-inch diameter spot drill. We'll create 7 actually. 6 will be used for the drilled and tapped holes. And then 1 will be used at the center of the pocket, and we'll drill through with a drill equal to the diameter of this hole. If I select this circle and hit F4, it is a 0.531 diameter hole. So I could actually use I believe that's a 17/32 diameter drill. We'll check, but I think that's 17/32, or at least within a 1/2 thou. So close out of this. Let's use a spot drill to create our pilots, and we'll create the 6 pilots for the tapped holes and 1 pilot for the drill that's going all the way through the part. So let's do this. Let's go to Toolpaths, 2D, Drill. Now we're getting asked to select 1 or more entities to add to or remove from the features list. So this is the features list. What I'll do, I'm going to select mask on arc. And then I'm going to select this circle right here, not the countersink. Actually, I will select the countersink. So I'll select the countersink. And it says use window select or Control A or the arc quick mask to find matching arcs. I'll just select this icon right here, the upper half of select all arc entities. No, I don't like the looks of this. See how it's selecting the ones on the bottom of the part? Should not have done that. Yeah, that would be a bad thing. See that diagonal line going to the bottom of the part? So I'll try that again. So if you're in the same situation as me, right click, delete or delete all. I'll select one of the circles. Oh, it's a solid arc. That should work. Over here, what are my options? Copy previous points. And actually, this thing's giving me some grief. So let me try this one more time. And then I'm just window selecting. And that didn't work well at all. See how it's grabbing that. So let's do this. Delete all. And I'm going to carefully select the circles. And when you select the circle, make sure the auto cursor isn't grabbing onto a quadrant. Make sure it's grabbing the center. And you'll know it's selected it properly when you see a point appear at the center of the drilled hole. Now that's not correct. You see that? So auto cursor point, delete. And the solid arc too, I'm going to delete this one too. Making a big mess of it. So I've got the 7 points selected. For the sort, I'll use a rotary sort, this first one. Select the center point. That's weird. All right, that's cool. So it starts here. And it goes in this order. Then when it gets to this point, it then drills the pilot in the center of the 3.5 diameter hole. And there should be 1, 2, 3, 4, 5, 6, 7 points total. So that was a little bit more difficult than I intended it to be. How's everyone doing with that?
How'd you click the so it was on top of the part?
I had to select the points. Usually what it does, it's like a mask plane or a plane mask. It only selects circles that are planar. And for whatever reason, it was grabbing points all over the place. So what I ended up doing, I ended up clearing out all the selected points from this field, and then carefully, when you zoom in and you get close to a circle, you want to make sure you're locking onto the center point. And once you left click on it, you'll see where that point is. And if it's on, say, a quadrant or a midpoint, you'll have to deselect or remove that selection from this field and then reselect it. It's kind of a pain in the ass.
Yeah.
How's everyone else doing?
And when we select the to drill through the part, we select the center of the top of the part, right?
That's what I did, yes.
Yeah, because at first I selected the bottom and it went through the part.
Yeah, mine was doing this diagonal move to these holes on the bottom. So that's not what we wanted. That would have caused a big problem. All right, so once you get to 7 points added to this field, select OK. That brings up the parameters for the drilling toolpath. let's go to the tool. We're going to add a 1/2 inch 90-degree spot drill to our tool list. So go to select library tool. You can see that the filter is still active. It's checked here. So select the filter icon. I'll start by deselecting all tool types, and then I'll select spot drill. For the tool diameter, I'll set it equal to 0.5. So spot drill equal to 0.5. I'll select OK. I've got one tool that fits that description. I'll double click on it, and it's added to my tool list as tool number 3. We'll need to make some changes to the tool definition. So right click on the tool and then select edit tool. I'll start by changing the tool geometry. For the cutting length, I'll match the cutting length to the drill tip length. So set this to 0.25 and then set the shoulder length to 1. That'll complete all the changes that we need to make to this page. From here, go to next or select next. With drills, to get Mastercam to calculate the feed rate correctly, set the number of flutes to 1. So number of flutes set to 1. To calculate the RPM, I'll select the calculator. And to turn the coolant on, I'll select show more options. I'll select coolant, and then I'll set the flood coolant to on. And from here, I'll select OK.
So did we set our overall length to what, 4 or 5 again?
I said it. I left it alone. We're not going to. It's the current length of this is fine.
Okay.
So, yeah, we're not going into the bottom of the pocket. So the current length, the current length will work. Yeah.
Okay.
All right. So from here, I'll select finish. The RPM is based off of this 150 SFM. And then the FPT. So when you're dealing with drills, think of the FPT as FPR. So set this to 2% of the tool diameter. So the tool diameter is 0.5 times 0.02. That's setting my FPR to 0.01 or 10,000ths of an inch. My feed rate is calculated at 11.46 inches per minute. From here, provide some type of comment. I'll borrow the tool name. I'll paste it down here, and we'll say drill all. It could be all caps once again. And that'll complete all the changes that we need to make to this page. How's everyone doing?
Are we gonna have pilot holes on the outside of the part too?
Yeah, we will, but those are going to be on a different operation. That's a third operation. So this is a
okay. So
yeah, all good. Okay, so yeah, this is going to be a 3 operation part, and we're not going to get to these drilled and tapped holes until the final operation, third operation. So from here, go to the holder. And let's use a Cat 40 ER32 tool holder. Select Open Library. Go to Cat 40 inch, and then select Open. Use a C4C3-0032 and set the tool projection to 1.5. So C40C3-0032, this is a ER32 tool holder. Tool projection, 1.5 inches. From here, go down to cut parameters. And I'm just checking to make sure that the cycle is a drill / counter bore with the dwell value set to 0. This will create a G81 drilling cycle inside of our NC file. From here, go to, let's see here, linking parameters. Let's set the clearance plane to 2 inches above the top of the part. So I'll start by turning on clearance. I'll set it to absolute. I'll select the clearance icon. This allows me back into Mastercam, and I can select something that I can lock onto that represents the top of the part. So I'll lock onto this endpoint, left click. It places that Z value in this field, and then you can just type in +2. Now, if you don't like the number, it's 4.355. You can round it to something that's a little bit more, a slightly cleaner number, call it 4.5, something like that. I've got that set to absolute. I will check use clearance only at the start and the end of the operation. For my retract, I'll set this to 0.1 incremental. For the top of the stock, I have it set, I'll set it to absolute. And then I'll use the top of stock icon. And once again, let my cursor lock onto something that represents the top of the part. For the depth, I'll set it to absolute. And then I'm going to use the depth calculator. I'll check overwrite depth. And then for the finished diameter of the countersink, if you look at the blueprint, and let's see, I'll pull it over from my other screen. The call out for this hole, it's got a countersink 0.265 in diameter by 90 degrees. We're using a 90-degree spot drill, so the angle's taken care of, but we can control the diameter with this field. So in this field, 0.265, I've got overwrite depth checked, and then I'll select OK. Make sure you don't have tip comp turned on. I've got it turned off, but you want to double check this. If you leave this on, it's going to drill deeper than you expected, probably scrapping your part. From here, I'll select OK. And with just that selected, with just the new toolpath selected, I'll run it in backplot. I didn't see anything that's going to be a problem inside of backplot. So I'll exit backplot. I'll toggle off the visibility of the new toolpath. I'll select the entire toolpath group, and I'll save my work. From here, I'll go to verify. Stop condition collision is still turned on. Then I'll select play. If I zoom into the drilled holes, you can see that the machined model matches the diameter on the wireframe, the diameter of that countersink on the wireframe. So that all looks good. So from here, I'll exit out of verify. And this is a good time to save my work. How's everyone doing?
Good.
Good? Nice.
Okay.
All right. So if you have any issues, feel free to ask. The next thing that we need to do is we need to create the stock model that reflects all of the machining up to this point. To do that, start by making sure that the insertion arrow is where it needs to be. In this case, at the very end of all my toolpaths. I'll go up to the toolpath tab, and then I'll select stock model. For the name, I'll call this a spot drill, or call it drill pilot holes. For the initial stock shape, I'll use an existing stock model. So I'll expand this menu and I'll select a contour outside profile. And then for the source operation, I'm going to select the new drilling operation. I'll select OK. And you can, and you can now see the stock model overlaying our part. Everything looks good. So from here, with just the new stock model selected, I'll toggle off display. And we're now ready to move on to our next toolpath. How's everyone doing?
Okay.
No issues? Nice. All right, so from here, we could go a couple different directions. We could spot drill, we could drill and tap the holes, or we could start machining this pocket. Now, I'm going to machine the pocket, but before I do that, I'm going to drill all the way through with a drill slightly smaller than this hole. And the logic being, I actually want to take a flat end mill and machine this wall right here. I want to get a nice machine surface on this face right here. Reason being, when we flip this part over, let me make the stock model visible again. When we flip this thing over, we're going to hold it in the vise, and we're going to have this big round disc sitting on top of our part, making it very difficult to set an origin off of. So what I'm going to do is I'm going to drill a hole, run a contour toolpath on it, and make a nice precise hole. It doesn't need to be that precise, but for what I'm using it for, it's going to become the origin for the second operation. So when this hole exists, I'm going to flip the part over. When I'm doing the first operation, I'm going to flip the part over, hold on to, say, this flat and this flat. I have opposing flats, so I can hold it in the vise at that point. I will either drop an indicator in that hole, sweep the hole, and establish my X0, Y0. Or if you have a probe, you can just drop the probe in the center of the hole and run a probing cycle to establish your XY, X0 and your Y0. So we'll talk about that when we get to it. So for now, let's just take a drill slightly smaller than 0.531 and drill a hole that goes all the way through the part and all the way through the bottom of the material. So let's do this. Let's go to toolpaths, 2D, drill. I'll select, now I don't have I could select this circle here. I could select this circle. I'm just picking up the center point. These two circles or these two holes are concentric. So I'm actually just going to lock onto this top circle. Left click. And you'll see a point up here. It's centered on that selected circle. I'll select OK. I'll go to the tool. Let's add a tool a drill that's slightly smaller than 0.531. I'll go to select library tool. I'll go to the filter. I'll deselect spot drills and I'll select drills. For the tool diameter, set it to less than, and I measured the hole, it's 0.531. I'm looking for a drill that's probably, 15 thousandths smaller than 0.531. Let me retype that 0.531. I'll select OK. And they've got it in ascending order. So smallest to the largest. Something you can do from this menu, if you select on the diameter right here, I didn't change it. Usually it flips it to the, it'll change it from ascending to descending. There we go. So now if I click on diameter, there's the smallest, there's the largest. So it just flips to the order that we're viewing them in this menu. I've got a 33/64. It's around 15,000 smaller than the hole that goes through the part. So this will work. So I'm going to select tool 163. It's a 33/64 diameter drill. So you can either double click on it or select it and then select OK. And that's now added to our tool list as tool number 4. We'll need to edit the tool definition. Right click on it to select it. Well, right click, and then select edit tool. Let's start by setting the, now we need to make sure that the length of the tool will go all the way through the part. So the default length is not going to work. So we're going to have to purchase an extended length drill. So let's start by setting the overall length to 5. We'll set the shoulder length to 3. And then I'll set the cutting length to 2.75. Now, in reality, what you would need to do is you would need to look at the manufacturer specs for the drill, or you'd have to physically measure the drill that you're using. So I just selected some numbers that would actually work in this particular case. Chances are you would have to actually measure the drill that you're using. From here, I'll select the next. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. You can calculate the RPM by selecting the calculator. You can turn on the coolant, select show more options, select the coolant, and then set the flood coolant to on. Select OK. And that should complete all the changes that we need to make to this page. So just to recap, number of flutes 1, I calculated the RPM, and I turned the coolant on. From here, I'll select finish. In these fields, the RPM's already been calculated. Set the FPT. Think of the FPT as FPR. This is a drill, so FPT is actually FPR. Set the FPR equal to 2% of the tool diameter. So I've got 0.515, and I don't need to carry it to 6 decimal places. So 0.515 times 0.02. It's calculating my feed rate at 11.44. And let's provide some type of comment. I'll borrow the tool name. I'll paste it down here, and we'll say drill pull through part. And I should make these all caps. How's everyone doing up to this point?
Okay.
All right. From here, go to the tool holder. Once again, we're going to use a Cat 40 ER32. So I'll go to Open Library. I'll access or I'll open up the Cat 40-inch library. And I'm going to use a Cat 40 ER32. So C4 C3-0032. Set the tool projection to 3.5. So C4C3-0032, tool projection is 3.5 inches. From here, I'll go to cut parameters. The cycle should have changed over to a pectoral cycle. This will create a G83 drilling cycle inside of our NC file. And the pec increment, this will be our Q word. This is equal to the drill tip length. From here, I'll go down to linking parameters. Now, a lot of these values are carrying over from the last drilling operation that we used. So these are good. And just want to do a, double check the numbers, but I can tell that this is good. This is good. Top of the stock, I don't quite trust it. So I'll select top of stock. And then I'll select something that represents the top of the part. And then for the depth, I'll set it to absolute. I'll select the depth icon. And I want to select something that represents the bottom of the material. I need this hole to go all the way to the bottom of the material so that the coolant can drain out. So I could select this endpoint, or I could bring the level manager back, make the material visible, and actually lock on to the bottom of the material. To get the drill to go all the way through the bottom of the part, I'll need to turn on tip. I'll need to turn on tip comp. Once you activate it, Mastercam will calculate the additional length for the drill tip and set the breakthrough amount to 25 thousandths. From here, I'll select OK. And I'll make the material level invisible. I'll go back to the toolpath manager with just that toolpath selected. I'll run it in backplot. Looks good. From here, I'll exit out of backplot. I'll toggle off the visibility of that new toolpath. Good time to save my work. And I'll select the entire first operation toolpath group, and I'll run it and verify. Stop condition collision is turned on. I'll select play. Now, if I back it up a little bit, and I can slow it down, the S key might work also. Yeah, so I'm single stepping. I've got a problem. See that? The drill, cutting length of the drill isn't quite long enough. Reason being is when I calculated when I was coming up with my cut length, I was only thinking of the part thickness. I wasn't thinking of the overall length of the material. So when I back this up a little bit, you can see that the shoulder of the drill goes beyond the top of the part. And the problem with that is we need flutes to evacuate chips. And if the flutes are buried beneath the top of the part and you're drilling for too long, the chips won't have anywhere to go, causing a big problem. So I'm going to need to go back in and modify my cut length of my drill. So I'll exit, verify. I'll go back into the parameters for this toolpath. And actually, I think I can access the tool from here. So if I left click on the tool, let's see where it takes me. Let's set the Let's go to overall length is 5. Shoulder length, we'll set this to 2.5. And then I'll set the cutting length to 3.
Could we like analyze the distance of the top of the stock to the bottom?
We
Find
could.
out, or
We could. And what you got to do is just go to Home, Analyze Distance. I select that face, and then I select that face. Didn't quite like it, so let's do it this way. I'll go from center. See if I can lock onto the center here.
can we turn the material on, or
Oh, I got it right there. See it?
yeah?
And the distance from the top of the part to there is, and I could have told you, now that I look back on it, it's 2.73. It's 20 thousandths less than the material length that we started with. So yeah, so 2.73. But that's a good way to double check your work. And what I did, let's go back to the tool geometry. The cutting length is 3, and the shoulder length is 3.5. Problem is, when I made a change to this, it's going to change my tool projection. So I'll select Finish. I'll go back to the parameters. Yeah, I changed my feed rate too. So set the FPT to 2% of the tool diameter. So 0.515 times 0.02. And then if I go to the holder, oh, it didn't change it. So at 3.5, we should be good. I'll select OK. I need to regenerate the toolpath. And let's run this in backplot again. If I look at it from a right side view, and if I make the stock visible, well, there's a couple ways we could do it. We could actually go to toolpath, turn this. Oh, my bad. Stock model disappeared. We haven't created it yet. Not stock model, my bad. Toggle stock display. And that's what I'm looking for. So you can see that the full diameter goes through the bottom of the part. And then you can see I still have some cut length on the top of the part. I actually have a little bit more than what we're seeing here. So this red area is already gone because we machined to the top of the part with the facing mill or the face mill. All right, so I no longer need to see the stock display. This would be a good time to save my work. And just to be on the safe side, I'll select the entire first operation again, and I'll run it and verify. Tumble my view. See the hole goes all the way through the part. Now the coolant will have a place to evacuate, and hopefully it carries some of the chips along with it. All right, so exit verify. Look at it from an isometric view. The next thing we'll need to do is we're going to machine the pocket. And this is one of those scenarios where we could have ordered the two, I could have positioned the pocket after the contour. And what,
I have a question, Patrick. Are we
Yes,
going to
sir.
create a stock model for?
Yes, we will. Yes, we will. I forgot. I got caught. I got caught up in a thought on how to order these tools. So
Okay, no
let's
problem.
let's create the stock model right now. Then I'll talk about what we need to do. So for we're going to create a stock model that reflects all of the machining up to this point. Make sure the insertion arrows at the very end. Select stock model. And you can call this the 33/64 hole through. For the initial stock shape, I use an existing stock model. I'll select the drill pilot holes. And then for the source operations, I'll select that new drilling operation. I'll select OK. And now you can see that the hole goes all the way through the part. And I'm rethinking the order that we did this in. We should have faced it, drilled our pilots, drilled the hole through, and then did the contour, and then went right into the pocket using the same tool. So don't worry about it right now. This is extra credit. We're going to call up a pocketing tool path, and we're going to machine the pocket with a 1-inch diameter flat end mill. But in hindsight, I would order my tools a little bit differently. Don't worry about it for now. Just I wanted to point that out, that if we would have faced it, spot drilled, then drilled, and then I could have machined the outside contour and then the pocket that way I could have avoided a tool change, making it a more efficient program. But we're all right. So what we're going to do now is we're going to machine the pocket. But before I do that, I'm going to make the stock model invisible. So with just this new stock model selected, I'll toggle off the display and I'll save my work. How's everyone doing?
Okay.
Good. Nice. All right. We'll use a pocketing operation to machine out the pocket. And the surface finish doesn't need to be great, but so we're going to rough and finish with the same tool.
So if we wanted to, we can go back in and change the geometry of the chain.
Change the geometry. I don't know if I would change the geometry.
You just add one, right? You just add it.
No. What I would do is because one's a contour operation, one's gonna be a pocketing operation. You're talking about combining the two operations in one tool path.
Okay.
I see where you're going. If there were two contours, we could, but one's a clearly machining an outside or an external feature, and the other one's machining a pocket. So
Okay.
it wouldn't work that way.
Yeah. So you're just considering not not changing the tool part. That's it, right?
Exactly. I was just thinking of eliminating a tool change.
Okay.
So, so from here, we're going to create a pocketing operation. We use 1-inch flat end mill. It's already in our tool list. So go to tool paths, 2D. Now I don't see the pocketing tool path available, so I'll select expand gallery, and then I'll select pocket. And it says select pocket chain number 1. So we're actually going to select 2 chains. I'm going to select the top edge of the part. I'm sorry, the top edge of the pocket so that it goes in a counterclockwise direction. And I see it's going in the wrong direction, so I'll flip the direction. And then I'm going to add a point. So while I'm still in the wireframe chaining dialog box, I'll select point. And then I'll lock on to the center of the circle that I just selected. And you'll see a point up here. So we added 2 items to our chaining list. From here, I'll select OK. You'll see that there's 2 items here. From here, go to Tool. I've got the 1-inch flat end mill selected. The RPM and the feed rate, I'm sorry, the RPM is already calculated, but the feed rate is incorrect. So set the FPT to 1% of tool diameter. So 0.01 times 1 is 0.01. Set the plunge rate to half the calculated feed rate. So 34.38, divide that by 2. And from here, let's update the comment. And it's got some information from the last time we used the pocketing toolpath. This isn't going to work, but I can leave the, what I'll normally do is just copy the name, paste it down here. Let's say machine 3.5, and I'm double checking that, diameter pocket. And that'll complete all the changes that I need to make to this page. Now the tool holder's already been selected. Cut parameters. Machining direction should be climb. Pocket type should be standard. And for stock leave on walls, I've got to set to 0. Stock leave on floor, set to 0. Go to roughing. Use parallel spiral, not parallel spiral clean corners. Use parallel spiral. And then I'll accept the default values for all, or the default settings for all of these items down here. For entry motion, I'm using Helix. Minimum radius, 25%, maximum radius, 50%. Make sure you have center on entry point checked. The entry point being that point that we selected when we selected the chain. From here, go to finishing. I've got number of finish passes set to 1. First off, activate it. I've got number of finish passes set to 1. The spacing should be 2% of your tool diameter. For compensation type, I've got it set to wear. I got to keep tool down. Machine finish passes only at the final depth, and I'm going to uncheck machine finish passes after roughing all pockets. So match your settings to mine. Go to lead in, lead out. And I'm just double checking that these are the default values that I have set, 25% for everything. Once you verify that, go to depth cuts. Turn on depth cuts. Max rough step should be set to 50% of your tool diameter. This is a setting when we use tool step peck and coolant. I can select, I'm not going to keep tool down. Yeah, so this is all good. Breakthrough. If you see breakthrough, if breakthrough is turned on, turn it off. This will cause it to machine too deep. Linking parameters. Once again, set your clearance to 2 inches above the top of the part. So I'll turn on clearance. I'll select absolute, and then I'll select clearance. And then I'll let my cursor lock onto something that represents the top of the part. This value is the top of the part. Add 2 inches to it, +2. For the retract, set it to 1/4 inch above the top of the part. So I'll set it to absolute. I'll select the retract icon. Then I'll let my cursor lock onto something that represents the top of the part. Now this value is the top of the part. Add 1/4 inch to that, so +0.25. Feed plane, set it to 0.1, incremental. Top of the stock, absolute. I'll select the top of the stock icon, and then let my cursor lock on to something that represents the top of the part. For the depth, I'll set it to absolute. I'll select the depth icon. And this time I'll let my cursor lock onto something that represents the bottom of the circular pocket. And that should complete all the changes that I need to make to these parameters. From here, I'll select OK. You can see that it machines it in 1, 2, 3, 4 depths of cut. Then it does a helical entry to each depth of cut. And when it gets to the final depth of cut, it does a finish pass. So with just this toolpath selected, I'll run it in backplot. I didn't see anything out of the ordinary, anything that I should be concerned about. One thing that Josh and I were talking about last class, if you go back to the parameters and you go to the helical entry, let's go to entry motion. Change the direction to counterclockwise. Regenerate that. And let's see what it looks like with the entry motion going the other direction.
Looks good.
Looks better, right?
Yeah.
And if you slow it down, you can really see what it's doing. So there's the helix. I think it's going to do one more pass. Yeah, I think I like that better. In my mind's eye, it's climb cutting for the entire machining operation, whereas it was conventional cutting and then it was doing a change in direction, which I didn't like at all.
That's changing spindle direction, right? Just the motion.
No, the spindle's still going in the right direction. It's the XY or the direction of the tool versus the rotation of the tool is still going in the same direction.
So the
direction of the tool is changing. Yeah, I don't like it. It's not. I would like to run a test with this on a forgiving piece of material and a tool that I'm not too concerned about. Does that make sense?
Yeah.
So run a little test and see what the results are. So anyway, I'm going to leave it that way. It looked good inside of backplot, so I'll toggle off the visibility of that toolpath. I'll select the entire toolpath group, and this would be a good time to save my work. I'll run it and verify. Inside of verify, make sure stop condition collision is turned on, and then run it. I think it looks good. So from here, I'll exit verify. The next thing we'll need to do is we need to machine a pocket and then a contour. And I would like to do it with the same tool. So if I select this circle and hit F4, the diameter is 1.1024. And then this hole here is 0.515. At least that was the diameter of the drill. Might have drilled a little oversized, a little undersized, but it's in the neighborhood. I'm thinking I can use a 3/8 diameter flat end mill to machine this pocket and then to quickly machine this contour right here. I got to remember this contour is a little bit deeper than we're seeing here because it goes all the way through the part. And I want this to be a nice machine surface is because this is where I'm going to set my origin for the next operation. I'm either going to sweep it with an indicator or I could drop a probe in there. If you have a probe, you can drop a probe in that hole and then set your XY origin at the center of the hole. So I'll exit out of the arc properties. Let's use a pocketing toolpath to machine this 1.1024 pocket.
So will that all share the same stock model because it's all one still a pocketing operation?
No, you're right. I need to take a step back and talk about or create the stock model. But that's where we're going to go next after we create the stock model. We'll have 3 separate stock models. I could combine this one and this one, but we're gonna create new stock models for each one.
Okay.
All good?
Just to verify or
just practice, verify. You know, it's we're just, you know, through repetition, we're becoming pretty proficient in what we're doing.
Yeah.
So let's create a pocket to machine this 1.1024 diameter pocket. We'll use a 3/8 diameter flat end mill to do it. So I'll go to toolpaths. I'll go to pocket. Now it's not available here, so I'll select expand gallery. Select pocket. And the wireframe chaining dialog box appears. I'll start by selecting the top edge of the 1.1024 diameter pocket. And I'm actually still in point selection mode. So deselect everything. And let's see here. Didn't want to do that. Oh, didn't want to do that either. Hold on. Yes, I do want to keep that operation. So add chain. Now this is where you guys should be at. Go back to chain selection method. Select the top of the circle or the top of the pocket so that the chain goes in a counterclockwise direction. Now I didn't realize it, but I could have easily, you know, kept that point. Didn't want that either. I'm screwing up. So select center here. Now I'll have to delete that point, so I'll select OK. That point's got to go. So right click, delete. Now I just have a chain and I have a point in my chain manager. From here, I'll select OK. I'll need to go into the parameters for this toolpath and start by going up to the tool. We're going to add a 3/8 diameter flat end mill to our tool list. So go to the tool, select library tool. The filter is active, so select the filter icon. And we're looking for a flat end mill equal to 0.375. I'll hit enter. I'll select the green check. I've got one tool that fits that description. I'll double click on it. Maybe. And it's added to my tool list as tool number 5. I need to edit the tool definition. So right click on the tool, select edit tool. The depth of this pocket. Now I'm looking at the drawing. The depth of this pocket is 0.3125. So make sure that the cutting length is greater than the depth of the pocket. In this case, it is. Overall length is 2.5. So from here, this page is good. I'll select next.
So did we bring in a new tool for this?
Yeah, we're using a 3/8 diameter flat end mill. Yeah, so add a 3/8 diameter flat end mill to your tool list and then edit the tool. I didn't do anything to it on the first page. The tool geometry, left it alone. So I'll go to next. For the number of flutes, I'll set it to 3. And then I'll select the calculator to calculate the RPM. To turn the coolant on, I'll select show more options, select coolant, and set the flood coolant to on. I'll select OK. And then for the finish XY step percentage, set this to 2. So number of flutes 3. RPM has been calculated, the coolant's on. So from here, I'll select finish. And RPM is good. Let's set the FPT, the feet per tooth, to 1% of the tool diameter. So decimal equivalent of the tool is 0.375 times 0.01. I meant to say 1%. So 1% of the tool diameter. It's calculating my feed rate at 34.38. Set the plunge rate to half the calculated feed rate. So 34.38, divide that by 2. And let's provide some type of comment. So I'll borrow the tool name. I'll paste it down here. Let's say machine 1.1024 diameter hole or diameter bore. That'll complete all the changes that I need to make to this page. From here, I'll go to holder. We're going to use a solid type tool holder. So it'll be Cat 40. I'll go to open library. I'll select Cat 40 inch. I'll select open. And from this list, let's choose a C4, I believe E4 0375. Yeah, it's not available in the E3, so go to a C4 E4 0375. And let's set the tool projection to 1.5. Now this is going to be close because we're dropping this tool and tool holder into this pocket. And what we don't want to do is we don't want the tool holder to come into contact with this inside wall. So C4 E4-0375, tool projection 1.5. Go to cut parameters. Now, a lot of these values are carrying over from the last time we used the pocketing toolpath, so they should be good. I'm not leaving anything on the walls. I'm not leaving anything on the floors. For roughing, once again, I'm using parallel spiral. I'll accept the default values here. Entry motion. Once again, these values should be good. Now, something that we could do, I'll just leave it alone. Because there's already an existing hole, we could, increase these values, but we'll just let it alone. So helix, helical entry, minimum radius is 25%, maximum radius is 50%. Finishing, I've got finishing activated. I've got number of finish passes set to 1. The spacing is set to 2% of the tool diameter. And then I'll accept all the default values. Lead in, lead out. Once again, this should be 25% for everything. These are my default values. Depth cuts. I have depth cuts activated. If the pocket is deeper than half the tool diameter, it will do it in multiple depths of cut. Breakthrough. Make sure breakthrough is turned off. This will cause it to machine the pocket too deep. And then go to linking parameters. All of these values are carrying over from the last tool path, last pocketing tool path. For the top of the stock, make sure it's set to absolute. Use the top of stock icon, and you're going to pick select the top of the 1.1024 diameter pocket. And then for the depth, you'll select the depth icon. Before you do that, though, make sure it's set to absolute. Select the depth icon, and then let your cursor lock on to the bottom of the circular pocket. And that should complete all the changes that we make to this operation. I'll select OK. I'll need to regenerate the toolpath. I'll select regenerate all dirty operations. And then with just this toolpath selected, I'll run it in backplot. I'm going to look at it from a top view. And I'll select play. And what I'm looking for is contact with the tool holder. Now, this is the largest diameter of the tool holder. But you got to remember, this is what's more likely, this is what's going to come into contact with it. So if I look at it from a top view, if the larger diameter doesn't come into contact with the inside wall of the pocket, or this inside wall that I'm tracing with my cursor, we should be good. So I'll select play. Yeah, so you can see that we've got clearance. It gets close, but at no point am I seeing the largest diameter of the tool holder break out of this diameter that I'm tracing with my cursor. So I think we're good. I'll exit out of backplot. I'll toggle off the display of the selected tool or selected tool path. I'll select the entire toolpath group. This would be a good time to save my work. And I'm going to run the entire toolpath group. And I forgot to create a stock model. I can see that already. So we'll backtrack, but I'm going to run this entire toolpath group inside of Verify. Stop condition collision is turned on. And I'll select play. All right, so pocket looks good. If I zoom in, I can compare the machine model to the wireframe model. Everything looks to be correct. So from here, I'll exit out of Verify. I'll look at it from an isometric view, and I'll save my work. I need to create a stock model for two operations. I'll start by creating the stock model for the big pocket. The insertion arrow, you can see that's currently at the very end of the toolpath group. I'll bring it up one tool. I'll bring it up, I'll place it in front of the last toolpath. I'll then go to stock model. And I thought I created the stock model for this one. What did I do?
No.
I thought I named one 3.5 bore. What's this one called? Hold on a second. Yeah, there's the through hole.
That's your description for your tool.
Yeah, this is a stock model. See the 3.3, the 33.
That's your drill. You machine, see the, highlight your pocket and see what you named your tool description.
Got it. That's right. That's right.
But
I'm losing my mind. So yeah, you're right. That was the description of the. That was a comment in my tool hole or the tool path. So you're right. It's late. I'm tired.
Yeah, I asked you about it, and then you just like went ahead and was like, nah.
I had my eye on the something else. All right, so let's call this one. This is the roughing of the pocket. So 3.5 diameter pocket. Select for the initial stock shape, we'll use the 33/64 hole through. And then for the source operation, we'll use this one right here. That first pocketing operation. I'll select OK. And there's a stock model for the 3.5 diameter pocket. I'll toggle off the visibility of that stock model. I'll reposition my insertion arrow. From here, I'll go to stock model again. Go to stock definition. This will be called 1.1024 diameter pocket. For the initial stock shape, I'll set it to the 3.5 diameter pocket. And I spelled diameter wrong there, so I'll have to go back in and fix that. Forgot to select the source operation, so I'll go back into it. I'll need to regenerate it. Now there's the stock model. No, I didn't name this one properly. So yeah, right there, that one. So I'll expand that, go into the parameters. Better. All right, so I've got two pocketing operations. We'll need to program a small contour tool or a contour toolpath for this pocket or for this existing hole. And then we're going to drill, tap, and chamfer all the sharp edges. So let's do this. We'll call it 7:05. I'm going to take 10 minutes. I'm going to take 15 minutes. I'll start back up at 7:15. So save your work. So I'm looking at from my symmetric view. I will save my work and I'll toggle off the display of any visible stock models that are on my screen. I've got what's going on here. So there we go. Okay, so all the stock models are no longer visible. And I'll save my work. All right, so from here, I'm going to use the same 3/8 diameter flat end mill, and I'm going to machine this pocket right here. It's not a pocket, it's a hole that goes all the way through the part, but I want a nice machine surface on this face right here. This is the face that we're going to set our origin off for the next operation. So I'm going to use a contour toolpath, and I'm still going to use this 3/8 diameter flat end mill. I'll go to toolpaths, 2D, contour. Under wireframe chaining, mode is set to C-plane, and selection method, set it back to chain. And then select the top edge of this 0.531 or this 0.51, this 0.531 diameter hole. I want the chain to go in a counterclockwise direction. I'll select OK. And that brings up the parameters for this contour toolpath. I'll go to Tool. And we're selecting a tool from the tool list, or an existing tool in the tool list. I'll select the 3/8 flat end mill. The RPM is still good, but we'll need to recalculate the feed rate. So set the FPT to 1% of the tool diameter, so 0.375 times 0.01. It's calculating the feed rate at 34.38. Let's set the plunge rate to half the calculated feed rate. So 34.38, divide that by 2. And from here, we'll need to provide some type of comment. So I'll borrow the tool name. I'll paste it down here. And let's say machine 0.531 diameter bore. From here, the tool holder has already been selected. We'll go to cut parameters. The compensation type should be set to where. The compensation type should be left. Stock to leave on walls is set to 0. Stock to leave on floors set to 0. I'm actually going to activate depth cuts because this is going through. You got to remember that we're actually going through the material. So there's this pocket or this wall is going to be deeper than it appears here. So I've got depth cuts turned on. Number of finish cuts for the depth, 0. I've got keep tool down checked. From here, I'll go to lead in, lead out. Now, this is a small diameter hole that's slightly larger than the tool that's going into it. So we might need to reduce these entry or these lead in, lead out values. Let's start by setting both of these to 10%. And then I'll carry it over to the exit. For the breakthrough, I'll turn breakthrough on and I have it set to 20 thousandths. Multipass, I have multipass turned on. I've got number of rough steps set to 1, and then number of finished passes set to 1, with the spacing set to 0.0075. Everything else here, match your settings to what you're seeing here. Finished passes is at the final depth. And then I've got keep tool down checked. From here, I'll go to linking parameters. Everything here is carrying over from a previous operation or from a similar operation that we used on this project. For the top of the stock, I have it set to absolute. Select top of stock and then select the top of the 0.531 diameter hole. For the depth, I've got it set to absolute. I'll select the depth icon and I'm going to select something that represents the bottom of the material. So you could select the bottom face here of the soft jaw, or if you just go back to the level manager, make the material level visible. Select the bottom face of the material. I'll select OK. Now I need to make the material level invisible again. So I'll go back to the material level, turn it off. Now if I zoom in, it's doing several depths of cut, and then when it gets to the final depth of cut, it does its finish pass. So that's what I want. With just that toolpath selected, I'll run it in backplot. Looks like we're okay. I don't see any rapid moves breaking out of the material or breaking out of the part. So I'll exit backplot. I'll toggle off the display of the selected toolpath. I'll select the entire first operation toolpath group. This would be a good time to save my work. And let's run the entire toolpath group inside of verify. So I'll select verify. So inside of verify, make sure stop condition collision is turned on, and then run it. If I zoom in, you can see we've machined this bore out. I don't have any collisions. So the next thing we'll need to do is we'll need to drill, tap, and deburr. So from here, I'll exit verify. We'll need to make a stock model that reflects all the machining up to this point. Make sure the insertion arrow is at the very end of all your toolpath make sure it's at the very end of all your tool paths. Select stock model. And we'll call this one the 0.531 bore. For the initial stock shape, I'm going to use the stock model from the previous operation. And then for the source operation, just select the contour operation that we just created. From here, I'll select OK. And then you can see the stock model being created. So Tyler, you said, did we change anything in depth cuts? Let me go back to depth cuts real quick. We're going to depth cuts. No, I accepted all the default values on this one. I didn't change anything. So, and a lot of these settings were just carrying over from the other contour toolpath that we use. So from here, I'll select OK. I'll minimize that contour toolpath. Now I have a stock model visible on my screen, so I'll select it. And then I'll toggle off the display. I'll look at it from an isometric view. And once again, I'll save my work. From here, we have, we need to drill. We already have the pilots. So we'll need to drill, tap, and then break any sharp edges that we might have created with the other toolpath. So I have a drilling operation already in this toolpath group. In my case, it's it's toolpath number 6. And it's already got 6 points, 6 of the points needed added to the geometry. So let's do this. You should only have one drilling operation in this toolpath group. Select it. You have a green check next to just that toolpath. Right click, copy. And then down at the very bottom, insertion arrows at the very end, right click, paste. And then expand that new toolpath. Now this copy toolpath has 7 entities in it. We don't need the one in the middle. So if I select geometry, it brings back up this the features menu. This is the one I don't need, arc 7. I'm sorry, this arc 9, this 3.5 diameter. If I select it, right click and delete, it removes it from this list. And now I'm only drilling the 6 points or the 6 holes. I'll select OK. So that was the first modification that we needed to make. From here, go to parameters, go to tool. We're going to add a number 7 drill to our tool list. Select library tool. The filter is active, so I'll select filter. In the diameter, so we're looking at drills. In the tool diameter, set it to equal. And if you know the diameter of a number 7 drill, it's 0.21. But if you don't know, you can type in Shift #7. So #7. And if you hit enter, it knows that it's a number 7 drill with a diameter value of 0.201. You can do that with any letter size drill or any wire size drill. So you type in pound the letter or pound the wire size. So this is a number 7, #7. And it brings up the diameter value for that particular drill. From here, I'll select OK. I've got one tool that fits that description. I'll double click on it. It's added to my tool list as tool number 6. I'll need to edit this tool. So right click on it, select edit tool. Things that we can change here. Set the shoulder length to 2. So our tool projection will be 2 inches. Go to the next page. Set the number of flutes to 1. Calculate the RPM. You see the RPM is being calculated based off of this 150 SFM, and this is a rounded version of it. Turn the coolant on, select show more options, select coolant, and then set the flood coolant to on, and then select OK. From here, I'll select finish. The RPM is good. We'll need to update the feed rate. Set the FPT. It's a drill, so think of it as FPR. Set that to 2% of the tool diameter. So 0.201 times 0.02. It's calculating my feed rate at 11.457. From here, we'll update the comment. I'll copy the tool name. I'll paste it down in the comment field. Say drill holes for quarter-20 threads or quarter-20 tap. That'll complete all the changes that we need to make here. Go to the holder. We're going to use a Cat 40 ER32 tool holder. So go to Open Library, select the Cat 40 inch, and then select Open. Select the C4C3-0032. Set the tool projection to 2. And that'll complete all the changes that I need to make on this page. So C4C3-0032, tool projection is set to 2. From here, go to cut parameters. It should have changed over to a peck drill cycle, peck increment being equal to the drill tip length. Go to linking parameters. The clearance and retract, these are all carrying over from the previous toolpath. These should be good. Top of the stock, it should be good. If you don't trust it, just select top of stock and then pick select something that represents the top of the part or the top of the hole. For the depth, I have it set to absolute. I'll select depth. If my model is correct, I should be able to pick select the bottom of the drilled hole. And I'm selecting the diameter at the bottom of the hole. I'll need to activate tip comp. I'll select tip comp. I'll turn it on. In this particular case, because it's a blind hole, I don't want to use additional breakthrough. So I'll set the breakthrough amount to 0. And that'll complete all the changes I need to make to this toolpath. I'll select OK. I'll regenerate the dirty toolpath. I'll look at it from a front view. I'll turn translucency on. And now with just that new toolpath selected, I'll run it in backplot. And instead of just hitting play and letting it run out, I'm hitting the S key. And I'm checking. I can't quite see it. So if I look at it from a right side view, I'll even get out of the translucent. I'll go over to the wireframe view. There we go. So there it's going to its full depth. Look at it from a front view. And now the profile of the hole matches the profile of the drill. So I'm just verifying that the full diameter is going to the correct depth. Once I see that that is correct, I'll select play and let verify run out. I'm sorry, let backplot run out. Everything looks good. I don't see any issues. So from here, I'll select the entire first operation toolpath group. I'll save my work. And then I'll run everything inside of verify. Once again, stop condition. Make sure stop condition collision is turned on. Everything looks good. If you zoom into the hole, you can actually compare the machine model to the wireframe model. Everything looks good. From here, I'll close out of verify, and I'll make the stock model that represents all the machining up to this point. Insertion arrows at the very end of the toolpath group. I'll go up to toolpaths, stock model. We'll call this name, we'll give this one, we'll call it tap drilled holes. For the initial stock shape, we'll select that last stock model, 0.531 diameter bore. Actually, I think the last one was, that's correct, 0.531 diameter bore. For the source operation, let's select that new pectoral operation. I zoom in, see the stock model has the holes in it. So from here, to toggle off the display of the visible stock model, I'll select toggle display. We need to create a tapping operation. We're going to select the previous drilling operation. It's going to have the same geometry, same top of stock. The depth will change a little bit, but for the most part, all the settings are already been set. So carefully select just the pectoral operation. Right click, select copy. Now, before you paste, make sure that you only had the pectoral operation selected. Next to the insertion arrow, right click, paste. You'll need to expand that new toolpath and then go into the parameters. The geometry is already good, so select parameters and then go to tool. If you look at the call out for this thread, I'm opening it up there. They got plenty of them open. Quarter 20 UNC 0.5 deep. So we're going to tap to a depth of 0.5. And then, what I would do with the machine is I would actually run one instance or run, tap one of the holes, measure the depth, and then adjust accordingly. So what this means, what this call out means is that they need a full thread depth of 0.5. They can't have partial threads. They need to have a fastener or a thread gauge. We need to go into a depth of 0.5 for it to pass inspection. So let's add a quarter 20th tap to our tool list. So select library tool, go to the filter, select none, and then you've got these two icons right here. You got tap right hand, tap left hand. We're using a right hand tap. Majority of the time, you're going to come across right hand taps, unless you're running spindles that might go on a car or something. But the majority of the time, you're going to use right hand tap. So select right hand tap, select OK. And I did something wrong. Go back to the filter. Right hand tap, set to equal to 0.25. And this will show us all taps that are equal to 0.25 in diameter. It should be 2. I'll select OK. Now I've got the quarter 20 and a quarter 28. The drawing is calling out for a quarter 20. So double click on the quarter 20. You can see it's added to our tool list as tool number 7. I need to edit the tool. So right click, select edit tool. From here, we're going to set the shoulder length. Now, this is a very poor representation of a tap. Mastercam is not good at representing taps with coming out of their tool library. So set the, let's see here, set the cut length to 1, and then set the shoulder length. Let's see, shank that's cutting length, shank diameter, overall length. What is the gray?
You have to press the arrow down there.
Oh, gotcha. Oh, that's weird. So set the shoulder length, let's say to, that's weird, 1.5. So from here, I'll go to the next page. Now, I don't use the calculator to calculate my RPM, and I'm not concerned about the number of flutes. But what I will do here is I'll turn on the coolant. So set the flood coolant to on. And then I'll select finish. Now with taps, depending on the material, I don't like to exceed, say, 500 RPM. I like to keep it underneath 500 RPM. Several reasons, chip evacuation being one of the biggest factors when I determine my RPM. What Mastercam needs to do is Mastercam needs to synchronize the movement in the Z-axis for every revolution of the tool. What does that mean? So the pitch, the distance from one thread to the next, is 0.05. And to determine that, open up a calculator. I've got a calculator opening up. So when you look at a thread and it says quarter 20, the dash 20, or the number on the very end of it, that represents the threads per inch. And to calculate the pitch, the distance from one thread to the next, you would take 1 inch, then divide it by the number of threads per inch, 20. So the pitch is 0.05. And that's what you're seeing here in the FPT. The FPT is the pitch, the distance from one thread to the next. These fields are interactive. So Mastercam won't allow you to select an RPM with a feed rate that doesn't match based off of this pitch. So if I change the spindle speed to 200, watch what it does to my feed rate. If I change my feed rate to 20, I double it, watch what happens to my spindle speed. So these two fields are linked, and this is what's calculating. This is what is determining the feed rate and the feed rate relative to the RPM, or the RPM relative to the feed rate. What Mastercam is doing is it's synchronizing the rotations per the motion in the Z. So for every rotation in Z, for every rotation, it has to move 0.05 in the Z axis. So 0.05 times 100 RPM, 100 rotations. This is the distance it would have to travel in 1 minute so that the threads would be synchronized, and it wouldn't break the tap. So probably a little bit too much information for this lecture. Just know that Mastercam is calculating the RPM, or the feed rate, based off of this FPT. So I like to keep my spindle speed under 500 when I'm tapping. I'm going to set my spindle speed to 200, my RPM to 200, and watch what happens to my feed rate. It's going to feed at 10 inches per minute. And we'll talk about this more next class. It's getting kind of late. So from here, I'll borrow the tool name. I'll paste it down here. We'll say tap quarter-20 holes. I should have capitalized that. From here, I'll go to the holder. I'll select a quarter-20 holder. So I'll go to Open Library, Cat 40 inch, open it up, C4C3-0032. So I'll select it, and then I'll select set my tool projection to 2. From here, I'll go down to cut parameters. When we selected a tap, it changed over to the cycle. It's setting it to tap. This will create a G84 tapping cycle in our NC file. Now, this is a better representation of a tap than you would see, over here. So where did I go? Hold on. So it's changing over to a tapping cycle because we selected a tap from the library. Go to linking parameters. For the top of the stock, select the top of the hole. For the depth, now watch how I do this. It's set to absolute. For the depth, I'll select the top of the hole. Make sure you select the right hole. And then in this field, minus 0.5. And I'll hit enter. For tip comp, I'm going to turn tip comp off. If you look, it's not going to give us any value because it's calculating the tip length at 0. So just turn tip comp off and then select OK. I'll need to regenerate this operation. So I'll select regenerate all dirty operations. With just that new toolpath selected, I'll run it in backplot. Now it doesn't show true threads inside of Mastercam. And the only thing it's going to do is it's going to open the hole up to a 0.25 diameter. So I'm not seeing anything that's going to cause issues inside of backplot. I'll exit backplot. I'll toggle off the display of the toolpath. It's already toggled off. And then I'll select the entire first operation toolpath group and I'll run it and verify. Stop condition collision is turned on. And then I'll select play. All right, so from here, I can inspect the machine model to the wireframe model. If you zoom into the holes, you can see that they don't show threads. That's just Mastercam, but they are good. So from here, I'll exit out of verify. I'll look at my part from an isometric view. I'll fit my screen, and I'll save my work again. And this is where we're going to stop for this evening. And next class, we will pick up with the deburring of the part, and we'll create any additional files that we'll need for the next operation.